Okay, this is Unit 2, Activity 3. It is not Unit 3, Properties of Organic Compounds. And in here we're going to look at solubility, so the ability to dissolve, and boiling point. When we look at organic molecules, we have to ask ourselves what kind of forces are holding them together. And there's three types of forces holding them together. The first type of intermolecular force is called a London force. That's where this force was discovered. More commonly, it's called a dispersion force. So this is the weakest type of force. And if you look at a molecule and all it has is carbon and hydrogens, and notice how we have a propane here and a propane here. If you know anything about barbecuing, propane's the gas, and the gas is being held together by these weak things called dispersion forces. Now this is one propane molecule here. The propane molecule itself is held together by covalent bonds, but dispersion forces hold these two together. If you have dispersion forces, you have low boiling points. Now, the more carbons and hydrogens you have, the more dispersion forces you have. So you do get a higher boiling point if you have more carbons and hydrogens. It's still a low boiling point. There's something else called like dissolves like. If you have things that have dispersion forces in them, like fats, fats will dissolve in fats. Propane will dissolve in hexane. Things that have dispersion forces are alike, and they will dissolve well together. Now, if you take a carbon chain molecule and it has other things attached to it like oxygen, what you get is you get dipoles. So dipoles are a little stronger. If you look up the electronegativity of oxygen, it's 3.5. It's stronger than the carbon, which is 2.5. So this little symbol here means slightly. So it's slightly negative, slightly positive, slightly negative, slightly positive. What happens is the slightly positive carbon will attract the slightly negative oxygen and form a dipole, also called a dipole-dipole. These will have medium boiling points. They will be able to dissolve well in other dipoles, but because they're close to dispersion, they're right beside it, they will also somewhat dissolve in here. Now, the third type of force, and the strongest one, is called a hydrogen bond. Now, it's a little misleading. It's not a hydrogen bond, it's a hydrogen force. But if you have an OH on one molecule and an O on the other, then you will get a hydrogen bond. I know what you're thinking. You're thinking that this one has an OH on it too. But all you need is an OH on one and an O on the other, and you can get a hydrogen bonding. This is the highest boiling point. So if you want to analyze boiling point, dispersions are low, carbon and hydrogen. Put something else on the carbon chain and it's medium. Put an OH or an NH on, and it's even higher in boiling point. The other thing you have to look at is how long the carbon chain is. The longer the carbon chain, the higher the boiling point. If you want to know how things dissolve together, if they're just carbon and hydrogen, they dissolve well together. If they are just OH or NH, they'll dissolve well. So this guy here would dissolve in water. Okay, this one here is called 2-propanol. And because it has OHs in it and water has OHs, they dissolve well together. If they just have O's or they just have Cl's, they will dissolve together. This here is far away from this, so they do not dissolve together. But if you're right beside somebody, like hydrogen bonding's right beside dipole, dipole's right beside dispersion, they will dissolve together. Please watch this video 2 or 3 times to pick up on what's going on here. But this is a good primer on Unit 2, Activity 3. I think it takes some very complex ideas and boils them down into some simpler ideas.